Alright guys, so today what I'm going to do is go over our trigonometry notes that we have to do for our class. So we're going to start with talking about the different trigonometric ratios. So first of all, what is trigonometry? Well, trigonometry is the study of the relationships of the measures, angles, and sides of triangles. For geometry, we will be focusing on right triangles. There are three primary trigonometric functions that we will be using in this class. They are sine, cosine, and tangent. Sine is the ratio of the leg opposite the referenced angle to the hypotenuse. Cosine is the ratio of the leg adjacent to the referenced angle to the hypotenuse. And the tangent is the ratio of the leg opposite to the adjacent leg. So which leg is opposite, which leg is the adjacent, which leg is the hypotenuse? That's actually all very important. So in this triangle here, I have taken two angles. I have one, angle A, highlighted in blue, and angle B traced and highlighted in red. The very first thing you should do when you are facing a trigonometry problem is highlight the referenced angle. Which angle are you looking at? And that is very, very important for determining which side is the opposite and which side is adjacent. Now, the hypotenuse is always the long side. It is across from the 90-degree angle, and it will always be the longest side. So regardless of what angle you're focusing on, the hypotenuse is always in the same place, directly across from the 90-degree angle. Now, which side is adjacent? So I highlighted angle A, which means that this side, side AC or side B, is the adjacent side. And the opposite side is the side that I do not have highlighted in blue, and because it is across from the right angle or the referenced angle. So adjacent means next to. Your angle will always be made up of your hypotenuse and your adjacent side. The third side is the opposite side. So always label your hypotenuse first. Then we have angle B, which I've highlighted in red. So you'll notice that now I have opposite written in red is over here, side B, and adjacent is the red side here, side A. Side A is opposite angle A. So the ratio of the opposite leg to the hypotenuse. So sine of angle A. So if we look at angle A, the side that is opposite is side A, and the hypotenuse is side C, A over C. Angle B, if we're looking at the opposite side, we have the opposite side of angle B is side B, and the hypotenuse is still C, so B over C. Now you will notice that angles are in capital letters and sides are in lowercase letters. This is something we have discussed many times in the past, but here it is coming into play in a very real way. Please make sure that when you're referring to angles, you use capital letters, and when you're referring to sides, you use the lowercase. Cosine is the ratio of adjacent to hypotenuse. So if we look at angle A, the blue angle, our adjacent side is side B, and our hypotenuse is side C, B over C. If we look at angle B, our adjacent side is A, and our hypotenuse is C. Notice how I've got them color-coded. So everything that's tied to angle B is in red. Everything that's tied to angle A is in blue. So adjacent for angle B, adjacent over hypotenuse is A over C. Now you can see here that the sine of angle A and the cosine of angle B are the same. They are both A over C. Sine of angle B and cosine of angle A are the tangent is the ratio of the opposite leg to the adjacent leg. So for angle A, the opposite leg is side A, the adjacent leg is side B. A to B, or A over B. The tangent of angle B is opposite side, which is angle B, over adjacent side, which is side A. Side B over side A. So the tangent of B is B over A. Right? We have a mnemonic here. We have so katoa. This is a very common phrase. So katoa means that sine is equal to opposite over hypotenuse. I write it either way. This is traditional, horizontally. But if you have trouble remembering that, you can put the big letter and then a fraction. Sine opposite over hypotenuse. Ka means cosine is adjacent over hypotenuse. And toa means tangent is opposite over adjacent. When we get to finding a missing side, you will need to make sure you know which side is which. Okay, so we did some examples here of how to set them up. So for for number 1, we focused on angle A first, and I highlighted it in blue. So sine is opposite, so my word opposite in blue is with a 5. Hypotenuse is 13, 5 over 13. My adjacent side for angle A is 12, and my hypotenuse is still 13. So my cosine is 12 over 13, adjacent over hypotenuse. Tangent of angle A, opposite over adjacent. Opposite side with the blue. Notice we're color coding here. Adjacent with the blue. Blue over blue. Opposite is 5, adjacent is 12, 5 over 12. So then they made angle C, this one right here, and I highlighted it in red. Again, my hypotenuse is still 13. It's in the same location, but now my opposite side is 12, and my adjacent side is 5. Notice every time I highlight the angle, the hypotenuse stays across from the right angle, and the adjacent side is the other highlighted side. It's the leg that touches the angle. So my sine of angle C, opposite over hypotenuse, is 12 over 13. Cosine, adjacent over hypotenuse, is 5 over 13. And tangent is 12 over 5 because opposite over adjacent. For number 2 and 3, I did have to come up with the third side. This is the Pythagorean theorem formula that I used to do that, and found that the hypotenuse of triangle WYX is 15, and the missing leg of KLM is 30. And I put in all the same information. You'll notice on number 2 and number 3, I have simplified the ratios. I will not take off points if you don't most of the time, but it's a good idea to be in that habit. So what are we going to do with trigonometry? Well, we are going to use it to find some missing sides and find missing angles. So when we look here, I have some step-by-steps. You can copy this later. Here's our step. First, we identify the referenced angle. We highlight the referenced angle. And then we're going to label the hypotenuse and the adjacent and opposite and adjacent sides. Note, the hypotenuse is always across from the right angle. Adjacent is the other highlighted side. Opposite is not highlighted. And we make a list of our givens. So here we have this angle. This is the one they gave us information about, so I highlighted it. My adjacent side is this side down here. My hypotenuse is 19, and my opposite is x. So O is x. A, I have no information. H is 19, and the measure of theta is 28. So I have opposite, I have hypotenuse. I'm going to look here. Which one tells me I use opposite and hypotenuse? It is sine. So sine of a 28-degree angle is equal to x over 19, multiplied both sides by 19, and I get that x is approximately 8. Number 2, I highlighted the given angle here in green. My adjacent side is 32. My opposite side is unknown, and hypotenuse has no information, but it is across from the right angle. So I fill in an x for O and a 32 for A. I have a measure of angle theta is 41. Opposite and adjacent, O and A, is tangent. So tangent of 41-degree angle is equal to x over 32. And we get 32 times the tangent of 41 is equal to x. Therefore, x is approximately 27.82. I multiplied both sides by 32. On number 3, we do the same thing. We are going to highlight the given angle. We have our adjacent side and our hypotenuse and the opposite side. My adjacent is x, my hypotenuse is 26, and the measure of the angle is 21. So I have adjacent, I have hypotenuse. In our SOHCAHTOA, that tells me I use ka. C, cosine 21 is equal to x over 26. multiply both sides by 26 to get 26 cosine 21. And we get x is approximately 24.27. You can run this portion through any scientific calculator. Finally, number 4. Again, we have our highlighted angle of 33 degrees, so the measure of theta is 33. We are looking across from our right angle to find our hypotenuse, which is x. We plug that in for h. Our other highlighted side is adjacent, so there's no information for adjacent. We're going to leave that blank. And our opposite side is 15. We have opposite and hypotenuse, so we're going to be using the sign. The difference in this one is that now we're looking for the denominator. So in order to find this, we would need to multiply both sides by x, which would give us x times the sine of 33. And then, because sine of 33 is actually a number in and of itself, in order to get rid of it, move it back to the other side, we need to divide both sides by the sine of 33. So if we do that, right, so when I divide both sides by the sine of 33, this one cancel, and so I get x is equal 15 over the sine of 33. If you skip from this step, the sine of 33 equals 15 over x, straight to x equals 15 over the sine of 33, that is acceptable. Right, so in our application problems, the only two things that we're adding are draw a picture, which can be extremely simple, and label the sides. We're going to highlight the information as well, highlight the angle, label the sides OA and H, list the given information, determine the ratio, solve for requested info. So Jake leaned a 12-foot ladder. When units are given, units must be returned against his house. If the angle formed by the ladder and the ground is 68 degrees, how far from the base of the house did he place the ladder? So I drew a right triangle. This is the house. This is the ladder. This is the ground. The angle between the ladder and the ground is 68 degrees. It's a 12-foot ladder, and we're interested in how far the ladder is from the house. So for A, I have x. For H, I have 12, and the measure of our angle is 68 degrees. Adjacent and hypotenuse means I'm using cosine. Cosine of 68 is equal to x over 12. Multiply both sides by 12. And we get 12 times the cosine of 68 equals x, or approximately 4.50 feet. Number 2, a ramp is used to load suitcases on an airplane. If the cargo door is 7 feet from the ground and the angle formed by the end of the ramp and the ground is 25 degrees, how long is the ramp? So again, I drew a picture with the right triangle. This is my ramp, this is my ground, and this is the distance between the ground and the cargo door. So the cargo door is 7 feet off the ground, and we want the ramp and the ground form a 25-degree angle, and we want to know how long the ramp is. So that means I have information about opposite, which is that it's 7. I have information about x, or hypotenuse, which is that's what I want to know. And the angle is the 25 degrees. Opposite, hypotenuse, so sine. Sine of 25 is equal to 7 over x. Again, same thing like we did up there. We just switch the x in the left. And we get that x is approximately 16.56 feet. Number 3, a wire is attached from the top of a 30-foot telephone pole to a stake in the ground. If the angle formed by the wire and the pole is 48 degrees, what is the length of the wire? And you need to pay attention to which angle they're telling you you have. So before we had the hypotenuse and the ground, but this is between the pole and the wire, which is the hypotenuse. Because the pole is connected from the top of, or the wire is connected from the top of a pole to a stake in the ground. So my pole is 30 feet. There's a 48-degree angle between the pole and the hypotenuse. And we have information about the hypotenuse and the pole. Adjacent is 30, hypotenuse is x, measure of angle is 48. Cosine of 48 is equal to 30 over x, and so therefore x is approximately 44.83 feet. Right, so now we're going to use trigonometry to find missing angles when given two of the sides. If you know which ratio, sine, cosine, or tangent of the angle, you can use the inverse, which is the same thing, sine with an exponent of -1, cosine, exponent -1, tangent exponent -1. This is read as inverse sine, inverse cosine, inverse tangent. You might also see them as arc sine, arc cosine, and arc. We use that information to find the measure of the angle, and we're going to round to the nearest tenth. So the steps are essentially the same. You highlight the referenced angle, label the sides. So here we have our hypotenuse, which is across from the right angle. We have our adjacent side, which is the other side that has touching the angle. And we have our opposite side, which is the side that is not touching the angle. We're going to list our given information. So our given, so we have our opposite is 15, our hypotenuse is 24. We are looking for the measure of angle theta. So we know that the opposite and hypotenuse is sine. So what we're going to say is that the sine theta 15 over 24. Now, yes, we could simplify that, but we don't need to here. Now, to get rid of the sine, because theta is a number, we have to take the inverse of both sides. Under normal circumstances, I would have you skip the step and skip the next one. So we're going to multiply both sides, take the inverse sine of both sides. And we just put the -1 in as an x. So if we take the inverse sine of the sine, that is going to cancel each other out. And I'm left with theta equals sine inverse of 15 over 24. What I'm going to tell you is that if you skip straight to this step right here, that is also fine. Because we know that since we are looking for an angle, we're going to use inverse sine, inverse cosine, inverse tangent. And for the rest of the problems, that is exactly what I will be doing. So let's go ahead and run this through a calculator. So we're going to go to find sine inverse. We're going to go function, inverse sine, 15 over 24. And we get approximately 38.7 degrees. And like I said, most of the time I'm going to skip straight to this step. But in this case, I wanted to show it to you. Moving on to number 2. We're going to highlight the given angle. So we have this angle right here. We're going to label our sides appropriately. So again, our hypotenuse is, sorry about that. I don't know why, but if you click too close to the top of the page, it will send you to the front. So our hypotenuse is across from the right angle. And so therefore I'm going to label this side H. My other highlighted side is adjacent. And my unhighlighted side is the opposite side. I have to make sure I'm paying attention because once that yellow, for some reason, there's a link here. All right. So we're going to list our givens. Sorry. We know that A is 8 and H is 11. And we're looking for the measure of angle theta. So if we look here, our mnemonics, SOHCAHTOA, sine, cosine, tangent. We have adjacent, we have hypotenuse. That means we're going to use cosine. Since we're looking for the angle, we are going to use inverse cosine. So the way that works is going to look is that we're going to have that x will be equal to the inverse cosine of adjacent over hypotenuse, which is 11 over, or 8 over 11. And again, from there, we can make an approximation of x, 43.3. Make sure you include the units. Right, number 3, highlight the given angle, label your sides. Hypotenuse is, again, always across from the 90-degree angle. Adjacent is the other highlighted side. Opposite is the unhighlighted side. List your givens. We have opposite at 20. We have adjacent at 37, and we have an unknown measure of our angle theta. We have opposite, we have adjacent. Opposite and adjacent means tangent. So I'm going to use the inverse tangent to find the angle. We always use inverse to find the angle. And we get 20 over 37 is our, and we get 28. Number 4. Again, still highlight the given angle. So I'm going to label the information given. So again, our hypotenuse is always directly across from the right angle. Our other highlighted side is the adjacent, and our unhighlighted side is the opposite. All right, so now I'm going to list my givens. I have adjacent is 18. Hypotenuse is 23. And our unknown angle, measure of angle theta, is going to be x. We have adjacent, we have hypotenuse, so that is cosine. So x is equal to the inverse cosine of the adjacent side over the hypotenuse. And we're going to get that x 38.5. And here's your shortcuts for moving on. Number 5, we're going to label the hypotenuse first. We're going to label the adjacent side. Remember, it's the other side that's not highlighted, or that's highlighted. And the unhighlighted side is opposite. List your given. So O is 40. H is 41. And the measure of angle theta is unknown. We have opposite, we have hypotenuse, opposite and hypotenuse. So x will be equal to the inverse sine of 40 over 41. And we get 77.31. So we're going to say that x is approximately 77.3. And remember, on Go Formative or on the classwork, you don't have to put x. Last one of these blank problems, regular problems. We have angle x, the unknown angle. We're going to label our hypotenuse. We have our adjacent side as the other highlighted side, and the unhighlighted side is our givens. We have O is 7, adjacent is 5. And the hypotenuse, or sorry, the theta, and we use x, like they did in the picture. I have opposite, I have adjacent, so we have x is equal to the inverse tangent of 7 over 5, and we get 54. Remember, I'm rounding these to the nearest tenth. Make sure you pay attention to what you've been asked to round to. So now we're going to go over some application problems. Same steps. Jaden is flying a kite and lets off 275 feet of string. If the kite is 150 feet above the ground, and assuming the string is straight, what angle does the string make with the ground? So again, we have that Jaden is flying a kite and he lets off the string. We know the string is going to be diagonal. And the kite is 150 feet above the ground. And they want us to know and find out what angle does the string make with the ground. Now, in this case, we are not going to worry about Jaden's height. We will worry about that later. But in this one, we're going to pretend like he's sitting on the ground. Step 1, draw a picture. Remember, if you use the right triangle tool, it'll draw a right triangle for you. And I am going to go ahead and label this picture with all the appropriate information. All right, so I've drawn a picture of a kite with a string. I'm going to highlight the given angle. It was 275 feet of kite string, 150 feet off the ground. And we're curious about what this angle here is. So again, find your hypotenuse. We're going to label that H. The adjacent side to the angle is going to be labeled A. Remember, that's the side that is touching the angle. We have it highlighted. And the opposite side will be the side that is not highlighted. So in this case, we have that opposite is 150. Our hypotenuse is 275, and the measure of the angle is our unknown, and that's what we're looking at. So we have opposite, we have hypotenuse. We can look here at our shortcuts. Hypotenuse is, so we're going to say that x is equal to the inverse sine of the opposite, 150, over the adjacent of, the hypotenuse of 275. Run that through the calculator. And again, if anyone tells you they can do all of this without a calculator, please ask them to prove it. Don't stress yourself out about using a calculator for trigonometry. All right, we've got 33.05. We're going to round that to 33.1. All right, moving on to number 2 here. We have a fireman leaned a 36-foot ladder against a building. If you place the ladder 7 feet from the base of the building, what angle is formed between the ladder and the ground? And so what we're going to do here is, again, remember that if he is leaning something against something else, that's our hypotenuse. It is also telling us that the ladder is 7 feet from the base of the building, and we want to know what is the angle formed between the ladder and the ground. So I'm going to draw a picture. I'll be right back. All right, so just like on all the other problems, we're going to start out the same way. You see I've got my building here, I have my ladder, I've got the ground. I'm super creative, right? All right, so highlight your angle. Always, 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 always highlight the angle. It will help, I promise. I'm not just asking you to do that to torture you. Label your hypotenuse. Your hypotenuse is, of course, always across from a right angle with the ground. The adjacent side is the other highlighted side, and the opposite side is the unhighlighted side. So if we list our givens, we have 7 for the adjacent. Our hypotenuse is 36. Our angle, we have adjacent, we have hypotenuse. Adjacent and hypotenuse is cosine. So our x will be equal to the inverse cosine of 7 over 36. And we get 78.8. Remember, because in this case units are given, units must be. So that is all of our basic trigonometry intro. We have our ratios, we had our finding a missing side and finding a missing angle. Later we'll talk about special right triangles, the 30, 60, 90 and 45, 45, 90, because those have some shortcuts for finding sine, cosine, and tangent. And we will talk about angle of elevation and angle of depression. So until then, stay safe, and I'll see you in class. Bye.